Well, hello everyone. Thank you so much for being here today. Good to see you all. My name is Benoit. I am a senior product manager at Unity and very excited to be here today to give you an update on UI Toolkit. So we have a packed agenda. I'll start with an update on the state of UI at Unity, and then we'll dive right into what's being released for Unity 2023.2, and then we'll wrap it up with some insight about what is currently in development. And we should have time at the end for some Q&A. So back in 2021, when Mechanistry were developing their Beaver Team city builder game called Timberborn, they got to a point where they asked themselves if they should be using UI Toolkit for their project. They used UGUI in early development of the game, which back then was the only solution Unity provided and supported. And they were pushing its limits as Timberborn grew more complex. A lot of times building elaborate screens and trying to get everything aligned together just broke layouts, and reusing assets was challenging since logic is tightly coupled with the view. And because the UI assets are not human readable, they were continuously running into merge conflicts. Some of them can be resolved automatically, but other times they're not, and they have to recreate the prefabs from the ground up. So they felt like they were being slowed down by the system. So they wanted to release Timberborn in early access on Steam, and when you do so, it's critical to be able to iterate fast and improve the game based on that early feedback. And you probably know that city builders are quite complex, and they wanted to make the game more approachable and just more intuitive so they could keep growing that player base. And you can achieve some easy win by improving the user interface of the game. So Mechanistry looked at UI Toolkit's roadmap and decided to take a deep dive in the technology to better understand its capabilities, but also its limitations. They thought it would be a good fit for their project and was worth migrating the entire UI before they released the game on Steam. And this would also be a good opportunity to clean up some of the code architecture and pay off some tech debt along the way. So a programmer and an artist sat down and recreated more than 60 screens and widgets over the course of a 9-month period. And soon after, building UI went a lot faster. So no longer have to deal with merge conflicts. It allowed them to have better separation of concerns for their UI logic. So now they can work on different parts of the UI simultaneously, and also test components in isolation, so resulting in fewer broken builds. It's also easier to create more complex, so they've added things like scalable UI and hidden menus into their game. But best of all, because they improved the UI, but also every aspect of their game, they achieved overwhelmingly a positive rating on Steam, and that's a great achievement. When we asked Pavel to share with us his experience with UI Toolkit in Timberborn, he said that in UGUI, making a working prototype can take 1, 2, or 3 days, depending on the complexity. But with UI Toolkit, you can have a working prototype in a matter of hours. And that makes a huge difference in productivity, especially when you build a lot of UI and you want to be moving fast in this highly competitive market. So if you want to learn more about their experience in using UI Toolkit, we've made this case study that gives you all the detail about it. And make sure to visit their website and check out Timberborn. It's a beautiful game, and it's a lot of fun. So it worked for Mechanistry and other games, but will it work for your project? And I get this question quite often, and we're not really the ones that are able to answer that for you. All I can say is UI Toolkit has been released and supported for many years now. And even though it's not yet at parity with UGUI, it remains a viable alternative for many projects. But we always recommend for you to do a thorough technical assessment and evaluate if the technology is a good fit for your project. You can also keep an eye on our roadmap. We're continuously releasing improvements, performance optimization, and adding new features. And speaking of new features, now we're going to go over what is being released in 23.2. So for this release, we focus on improving the foundation of UI Toolkit before we continue growing the feature set. So that work is divided in 3 main categories. We wanted to make it more efficient to build dynamic user interfaces and make it easier to create custom controls that are also more easier to configure. We also felt some of the system were a bit complicated and complex and difficult to grasp, so we updated the event system, which is now easier to operate and behaves more consistently. The new input system now has runtime support integrated and no longer requires UGUI in your project to use. And we've also added a few new controls to the standard library. And we improved the button, so now it can display icons with or without text. But for today, though, we're going to focus on the first category of features that will increase development velocity. And we'll go over them by building a very simple yet very common UI found in many games, just a player bar displaying a player's health and a player's name and health. In most cases, you need UI to display dynamic information reflecting the state of the game, right? You could be pulling data from a server or just updating game stats like a player's score or a player's health points, which will most likely change a lot throughout the session of the game. So here we have our UXML defining the UI, and how you would normally connect data to it is by using uQuery to retrieve each element by either their name or their type or a USS class and assign new value to them. And in the case of a player's health, you also need to ensure it's continuously updated throughout the session of the game, right? And the feedback we heard is that this can be a bit tedious for 2 main reasons. First, when you have many elements, it requires a lot of boilerplate code to write. And even though strings can have some advantages, string references have some advantages, it makes the contract between the UI and the logic a little bit tweaked. Like you only need to make one simple change in a UXML or USS and the whole thing breaks. And those changes are usually challenging to track down and fix. So what if instead you could define what kind of data to connect to the UI directly into the UXML? So this is where you would declare a relationship between the model and the view and have a much better separation of concerns. And at first glance, you're like, well, it's a similar amount of code, but what if all that new UXML code could be generated for you? Then all you need to do is connect your data source, and everything will be resolved automatically. So that's what we did. We built a new data binding system. It works for both runtime and editor UI. You're not limited to use data types that are supported by serialized property. Any plain C# object can be used as a data source. And you can target multiple properties on the same element, ranging from visual element attributes to style properties. And it's fully extensible. You can create your own binding types and attributes. So many of you also find it important for artists and designers to work closer with programmers within a project. So we made sure the UI builder can be used to create and modify most aspects of data binding using visual workflows. So you start by assigning a data source to a visual element, which will then be made available to all of its children. And you can decide at any moment to override that data source in your hierarchy if you need to, and this will take precedence over its parents. So when setting a data source, you have 2 choices. You can set a type, which is just a type information. There's no instance being created at this stage, so no binding will be resolved. However, this can inform the UI builder of what type is expected, so later on, when setting bindings, it can provide assistance for you. Or alternatively, you can set a scriptable object asset from your project, and this is an actual instance. So all the bindings you define in there later on will be resolved live in the editor. So this is very useful if you want to work with a representation of your data and play around with some values and see the changes live in the UI builder. And optionally, you can set a data source path if you want only a certain part of your model to be made available to your bindings. And to set a binding, it's as easy. You can either go through the triple dot menu or just right-click on an attribute or a style property, and you select Add Binding, and you will be presented with this new dialog that has everything you need to properly set a binding. This is where you can override the data source if you want to. And then you set the path of the property in the data source. So if an object or type was specified as a data source in the previous step, the UI builder can suggest a list of parameters to choose from. It provides auto-completion and gives you useful information about them. There's also an option for specifying a binding mode, and you have several options to choose from. So you could want an input field and a data source to remain in sync whenever there's a change in either of them, or just have the input update the source. In our case, we want the opposite, right? We want the source to update the UI. And there's also an option for if you want the UI to be updated once and only once, if you have, for example, localization strings. Then we'll go and click on Add Binding. Then you can notice the affordance in the inspector now informing us that the value is coming from a data binding. It's also telling us the binding is resolved because it's coming from a scriptable object. But the binding could also be unresolved, and that's a perfectly valid state. The system is just informing us that even though the binding is properly configured, it doesn't have any data source connected to it yet. So it's on us then to provide a data source at runtime, and when we do so, everything would be resolved as expected. We're also using that new affordance for communicating when the value is coming from other sources, such as inherited from a parent, coming from a selector, or a variable. And the tooltip provides a very useful information about its origin. So, like I mentioned before, any change to a connected scriptable object data source is immediately reflected in the UI. And that's true for the UI builder or the game view. You can also define your bindings only using C# code, if this is what you prefer. So if we recreate the same UI in code, this is what it would look like. There's an API for creating, modifying, and setting bindings, just as you would do through UXML or the UI builder. To define a data source for runtime bindings that can also be used for authoring or serializing purposes, you can use a common pattern like this one. So the serialization goes through the field, and the binding goes through the property instead of the field. So this allows you to do validation, change notification, or any other operation. And the third one is similar, but for auto-generated properties. So we didn't want the binding system to make any assumptions on how you want to manage and the updates from your data source. So by default, it would pull the data and update the UI on every modification without actually knowing or asking if anything has actually changed since the last update. So this works well for very simple projects, but doesn't scale efficiently. especially when you deal with a lot of bindings. So to increase performance, you can integrate both versioning and change tracking into a binding data source. And so you can tell the system what to update and also when to update it. These are optional features, but if you see bindings taking a lot of resources in the profiler, you may consider implementing them to minimize the processing overhead. To integrate versioning, you just implement the iDataSourceViewHashProvider interface. It enables the binding system to skip updating certain binding objects if the source hasn't changed since the last update. The interface also buffers changes, which is very useful when the data changes frequently, but you don't want necessarily the UI to reflect those changes. So in our example, for the health of the player, it could change many, many times during a single frame, but that information doesn't need to be conveyed to the UI on each of those occasions. So you buffer the changes, then you call the commit changes method to to notify the binding system that the data source has changed, and now I want to update my UI. And by default, UI Toolkit will update all bindings associated to a data source. So if you need more granularity, you implement the iNotifyBindable property change interface. This allows you to instruct the system to only update certain properties and not all the bindings. And of course, if you want to achieve optimal performance, you can implement both of those interfaces in your data source. Sometimes you need data to be converted between the source and the target of the UI. You might have data that is completely different from the UI. You could be using an integer or an enum to do a lookup in a table and retrieve some texture to be displayed in the UI. Or in some other cases, you might want a different representation of the data. For example, if you have angle that you want to display in degrees instead of radians. UI Toolkit comes with a list of pre-made converters, but you can also supply your own. So a simple example for our player health UI would be to convert a numeric value to a string and append a percentage symbol to it. You can define individual converters or group converters like this one, which are very useful to handle permutation on the same conversion. The method for adding a converter requires a delegate to convert a source type to a destination type, and the delegate must be a ref delegate to enable bidirectional usage. And then all we need to do is register our converter group. And once that's done, they can be assigned to a binding using an API or directly from the UI builder. So if we go back to edit our binding and go into the advanced settings, now we can assign our newly created converter. And because the UI builder is aware about the types of the source and the targets, it can propose only the converters that are compatible. And once assigned, the value is sent to the UI, converted as expected. Right? So as you see, the value did not change, right, in our data source, but now the UI has a different representation of it. So far we've been looking at data bindings, and it's possible to also have other kinds of bindings. The binding system comes with an extension class that provides what's needed to creating your own custom bindings. They can be useful if, for example, you're dealing with custom types that are not natively supported by Unity, or when you don't need a data source. So using an example, Unity is also using custom bindings to create other types of binding as well. One example is the serialized object data binding system for the editor UI, which is still available. We rebased it on a custom binding so we can have a shared implementation for all binding systems. And it's worth noting that since we have that, now we can continually improve it. So we're planning to have a deeper integration of that system with the new binding system and add supports like custom converters, for example. We're also developing a localization bindings for adding support for UI Toolkit in the localization package. So this is a perfect example of a binding having a different set of requirements than regular data bindings. So an example of a custom binding implementation. When the binding system tries to resolve a binding, it's going to call the update method and expects a binding result, hopefully successful. But let's say our localization system makes asynchronous operations to load string tables and then assign strings value to for a given locale. Then if those operations are still ongoing when the update method gets called, we just return a pending result to ask the binding to try again later. And then when it gets called again and everything is ready, we can set the property on the element to the translated text, and we do so using our converter groups because we want to make sure all the registered converters are taken into account when the value is assigned. And this time we can return our result as a success. And at the bottom here we have an example of a localized string binding in a UXML document. See, it looks a lot like a regular binding, but with its own specific attributes for fetching an entry into a localization table. Also notice it sits under a bindings element, just like data bindings, and you can have a mix of different bindings under that element node. And for those of you with a keen eye, you may have noticed this new UXML object attribute, and we're going to cover this in a moment. So our UI is bound to a data source displaying converted values, functioning as expected. But I think at this stage it's fair to assume that most players would expect an actual health bar instead of a textual representation. So I'm going to go ahead and create a custom element for that. So we'll create a new custom health bar by extending the visual element class. We only need two elements, a background color and another bar for displaying the actual representation of the player's health. And whenever the player's health changes, we need to make sure to update the width, right, of the player's bar accordingly. And then to allow our custom element to be used using UXML or the UI builder, we need to implement what we call the UXML factories and traits. So a factory is what creates instances of an element. It also takes care of generating all the inherited attribute of visual elements. And then for each property you want to expose to UXML as an attribute, you need to create a trait by specifying its type, its name, the name that you want to in the UXML attribute, and a default value. And then finally, during initialization, you need to get the value for each of those attributes and assign them to your element. So you told us that this requires also a lot of setup, and more so because you can't really predict what's going to happen into that init method. And because all of that setup requires a lot of strings to be parsed, we're kind of limited on how we can optimize instantiation times. So we improved how UXML gets serialized. We wanted to make it faster and more intuitive to create custom elements, and also while also providing the familiar Unity features you rely on, such as serialization, property drawers, decorators, and so on. So with UXML serialization, this is how you would expose UI elements to UXML. So we're going to go over the few differences. First, to declare a custom control, you now use a UXML element attribute, which replaces the UXML factories. Each attribute now only requires a UXML attribute, no more UXML traits. And the attribute name is automatically derived from the property name, although you can, if you want, specify a custom name, you can do so as an argument in the attribute. And the default values are directly assigned to the field. And it requires the class to be marked as partial, because we're using some source generator. So when your code compiles, we detect all of those attributes, and we add new code to your classes that handles the serialization. So now we can replace our standard label with our new health bar, and we just need to make sure that the data binding reflects those changes. We had a binding to the same health property in the data source, but now it targets the value property of our health bar instead. And that's pretty much all we need to do. There's no need to change any code or modify the data source in any way. Now with that, we can do even more. So let's add the ability to customize the health bar so it changes color when reaching a certain percentage. For example, it would start green. When the player reaches 60% health, it turns yellow, and red at 30%. And for maximum flexibility, we could have any number of those health markers, which could be of any color. So a regular player could have 3 colors, and an enemy boss maybe go through 5 of those. So let's go ahead and create a new class to define those markers, which we'll name health marker, and only needs a position and a color. And then we add a new property in the health bar element that will hold a list of those markers. So this is all fine, but UI Toolkit has no idea how to handle the conversion of our health markers into UXML. So, because when a system sees a UXML attribute, it knows that the field or the property is linked to an attribute in UXML. And Unity will automatically handle the conversion of values to and from UXML attribute strings as needed. And this conversion is done through the use of what's called a UXML attribute converter. So this is great because we can create our own custom converters to instruct the system how to go ahead with that conversion. And to do so, we create a new class that extends the UXML attribute converter. And then we just need to override 2 methods that instructs how to go from a type to a string representation and vice versa. And then at the bottom, you can see what that representation would look like in UXML. We have our 3 markers separated by commas with their positions and color. And of course, these can be picked up by the editor, and they can be edited like any other attributes. So this is great, right? We can extend custom data types by defining our own UXML attribute converter, but you can run into certain limitations as your data types become more complex, or you're dealing with large lists of objects, which would make the generated string either less readable or more complicated to manage. So the notion of a UXML object, which is essentially an element that can be a child of a visual element, has already been part of Unity. Well, in UI Toolkit. So if you have ever authored a multi-column list view or a multi-column tree view, you may have encountered them. They're essentially, like you would notice, a columns element which holds a list of columns. So we enhanced this feature and made it available for defining our own UXML objects. So here we're going to convert our health markers to use UXML objects instead. So as you can see, they look a lot like UXML elements. We're using UXML attribute for attribute declaration and the UXML object attribute instead of using UXML element. And just like UXML elements, it also requires the class to be marked as partial. Also noteworthy is instead of using the UXML attribute now, when using a UXML object fields, we introduce what's called a UXML object reference. This allows us to specify a name that will indicate that the UXML objects will be parented to an element with that same name. But it's optional. If you don't specify one, they will just be serialized at the root of the node. So that will generate that. So that's the UXML with now our new health markers, which is much more readable and scales a lot better, right? If we keep adding additional health markers, it's much more convenient to manage. And of course, you can edit UXML objects directly in the UI builder. So then the last thing we need to do is update the value property of the health bar. Here we can do validation, like an early exit, if the value hasn't changed. Then we look for some health markers that would match our new value. And if we find one, we assign its color of the health bar's background with the color of our health marker. And lastly, we notify the binding system that the value has changed, and we can update the data source. So there it is. Now our health bar is able to shift between different colors, any number of colors, and those markers can be authored directly in the UI builder. So now that we are using serialized fields through this new UXML serialization, we can support custom property drawers, just like a scriptable object or a model behavior. So those are very, very useful if you want to improve the usability of custom elements and custom types. So let's go ahead and add some predefined property drawers to our custom element. As you would expect, they can be used to decorate types, properties, UXML elements, and UXML objects. So here we're going to use a header decorator for making a dedicated section for our health settings in the inspector, so they're easier to find. And I'm a big fan of sliders for changing values, so we're going to add those to the position property of our health markers. We don't have time to go in depth on how to create custom property drawers. I mean, they're not a new feature. They've been around for a long time, though there's a lot of existing material if you want to learn more about them. I just wanted to let you know that they are now supported by the UI builder. So let's add a final touch to our UI. I found the color change between those markers to be a bit choppy. It would be more pleasing if the shifting of colors was a bit smoother. So this is a perfect use case for USS transitions, which have been around since 2021. So again, this is not a new feature, but they're great for this kind of UI. They don't require us to specify a start value or an end value. Anytime the value changes, it animates the transition between the existing value and the new one. And so for this case, we just want to set the background color to transition over 0.4 seconds. So again, same UI, now with more smoothness. So it's one of those simple changes that can have a big impact on how the UI looks and feels. Okay, so let's recap. We looked at how UI Toolkit now makes it easier to build and customize UI. With the new data binding system, makes it easier to connect live data to your UI, which also works at runtime. And the new UXML serialization streamlines the process of creating custom elements, but also provides better control on how they are exposed in the UI builder. So I hope you find these new features useful and improve your day-to-day as you work with UI Toolkit. And please let us know if you enjoy them or if you see anything that you would like to be improved about them. All right, so we're going to spend the remaining time we have to look at what we are currently working on. So what has been released in 2023.2 concludes the second phase, our roadmap. Now we're shifting our focus to provide the features and capabilities to make UI Toolkit our best solution for creating immersive and dynamic UI for games, but also XR experiences. So we're not going to cover everything in the details, but I wanted to highlight the most important ones, which were prioritized based on your feedback, which we always appreciate, so thank you. So we're working on a solution to animate complex screens like a startup screen or a result screen, and for that you need the ability to create keyframe animations and sequence them together, and even combine them with other kind of animations. The second area of focus is being able to create more sophisticated UI styling by using custom shaders. So we can produce advanced visual effects like blur, glow, drop shadow, or any other kind of visual enhancement. And thirdly, we also noticing an increase in requests for making games available to more players. So we're working to add full multi-language support, which includes right to left languages like Arabic and Hebrew. And like I mentioned earlier, we also want to make UI Toolkit work with the new localization package. So we're adding support for that. And Unity also recently released a new C# API to interface with native screen reader on mobile devices. So we're going to build on top of it. So UI Toolkit will produce UI that works with them out of the box, and we'll add support for desktop as well. And lastly, you requested to have UI that can be rendered in world space. So in our internal dev build, we're exposing this capability via the panel settings, which now has a new render mode option. So when selecting world space, UI can now have 3D transformation applied to it, and is fully part of the game scene. The implementation is not using render textures or similar methods. It's fully integrated into the render chain. So this allows for textureless UI to remain crisp and beautiful at any size or distances from the camera. And of course, all other UI Toolkit features works as expected, such as styling, animation, and input. We're, of course, super excited to be working on this and can't wait to make that available. And one last thing before we leave, we also have a new sample project in the asset store. We've heard that it's not obvious to how to get started with UI Toolkit, and especially how to create a code architecture that will scale well. So this project shows how to use certain design patterns like patterns with UI Toolkit, like the model view presenter, the state pattern, and how to manage many, many screens in a project, and many other things. So feel free to check it out. All right, that's all the information I have for you today. So thank you very much. Okay.